Hello everybody. We are going to present our project which is about design, manufacture and evaluate a waste heat recovery system for converting the exhaust heat of vehicles into a useful source of energy. Starting with the outline, first we will start with short introduction and methodology. Then we will go through some of the literature review. After that, design concept generation and evaluation will be introduced. Next, the parametric and detailed design, where the detailed drawings and design parameters will be illustrated. Then manufacturing process, where the procedure of manufacturing will be shown. After that, experimental results and discussion. Finally, the presentation will be ended by comprehensive and short conclusion. First part of our presentation is introduction. Nowadays, the research on energy field is done for two main goals. The first goal is to use renewable energy and reduce the dependency of fossil fuel. The second goal is to increase the efficiency of the system by converting the waste heat into a useful energy. In our project, we are focusing on four objectives. First objective is to develop statistical information to know how much heat lost from cars in Oman. Second, generate and select design concepts. Third, manufacturing and evaluating the generated concepts. Fourth, analyzing the experimental results. Now we will go through the methodology. Methodology is divided into two parts. Part 1 has two phases. Phase 1 includes project planning, achievement of previous studies, gathering scientific information. Phase 2 includes gathering the design concepts and then concept evaluation and selection. Part 2 includes one phase, which is a continuation of the previous two phases. Phase 3 includes manufacturing and then experimental investigation. Literature review. Energy lost from the engine. The thermal loss from the engine represents 62% of the total energy from the fuel. In this project, we will focus on the exhaust, which represents 33% of the total thermal energy lost. Continuing with the literature review, waste heat recovery techniques. Waste heat recovery has two concepts, heat to heat and heat to power. Heat to heat means converting the heat lost to a heat, and heat power means converting the lost heat to power. Under heat to heat umbrella, we have two techniques, phase change material and nanofluids. And under heat to power umbrella, we have two techniques, thermoelectric generator and piezoelectric power generator. Statistical data of internal combustion engine in Oman. First table shows statistical information of vehicles in Oman collected on August 2021. The table shows different engine sizes of the vehicles with the different types of fuel. It has been found that the total heat loss from exhaust in Oman is 432.45 gigawatt. Second table shows the increase of the heat loss from exhaust from August 2020 to August 21. The increase was 3.208 gigawatt. Moving to design concepts, generation and evaluation, design parameters. On our project, we are focusing on certain portion of the exhaust. That portion is shown in the figure, starting from point 2 till the catalyst. Our design parameters, such as engine size and exhaust length, is defined above the figure.
Next point is concepts generation and selection. So we generated 5 concepts, 4 of them were heat to power concepts, and the last one was heat to heat concept. So we selected the concept 1 after evaluation selection. It means by converting the waste heat through the thermoelectric generator to electricity and store it on a battery. After that we use it on cooling system. Then we move to configuration design. We divide the components into 3 main parts: measurement system, that include Arduino, wires, etc. Simulation of exhaust system, which is include the circular duct and exhaust itself, and finally waste heat recovery system, that include MPPT, battery, thermoelectric generators, and etc. Then we make a rough geometric layout, and it connect all the parts of all system to each other, starting from the fan, heater, thermoelectric generators, and ending with the cooling system. After that, in parametric design, we make a selection for thermoelectric generators. So we need to match 100 series and 30 series for thermoelectric sites. And we found this thermoelectric generator. We connect it with 3 in series and 3 in parallel to get enough voltage and enough current. After that, we make a selection for variable speed fan. So we need to matching the exhaust gas velocities. and fan velocities. Then we found this fan that's applicable. The third selection was for heater and circular duct. The heater specification was heat flux of 20 kW per meter square and a length of 2.4 meter, and can increase the temperature from 32 to 320 Celsius. So we need to calculate the length of it. So we used this formula and found it 1.74 meter. They will make drawings for some components like diffuser, outer cover, fan nozzle, and so to work with their dimension. Here is isometric view of the system and also for exhaust. The manufacturing process starting from cutting the duct and the exhaust, then bending the outer cover using bending machine, then we insert the exhaust inside the outer cover. After that we make the fan nozzle, and then we linked the duct with the exhaust, then we install the fan on the fan nozzle, then we make the heater connections. After that we install the duct, then we install the thermoelectric generators and the cooling system, and that's the whole system. To get the experimental results, we need some system measurements starting from temperature sensors. We use one in the duct and 3 on the exhaust, then the multimeter also to determine the voltage and current of the thermoelectric generators, and Arduino to see the readings of temperature sensors.
The matrix of the experiment is shown in this table, where our input parameters are the speed of the vehicle in km per hour, the air velocity produced by the fan in meter per second, and the inlet temperature to the exhaust. From the experiment, we can find the middle and outlet temperature inside the exhaust, also the surface temperature which is in contact with the hot side of thermoelectrical generators. And by multimeter, we can measure the total voltage and current. After conducting the experiment and recording the results, we found that at 30 km per hour, the surface temperature reached to 116 degrees Celsius, which enabled the thermoelectrical generators to generate 4.13 volt. Then we did some calculations to find the total power and the amount of heat losses through the exhaust. The system efficiency reached to 15.9%. Results analysis. We construct a number of charts to show the relation between different parameters in the system. So here we can see that the relation between the fan velocity and the outer cover temperature or the surface temperature is almost linear. So as we increase the fan velocity, the surface temperature will increase. Then we generate other charts that show the relation between the outer cover temperature and the total voltage. Since the outer cover temperature or the surface temperature has a direct effect on the total voltage, so as we increase the outer cover temperature, the total voltage increase. Last chart shows the relation between the heat losses in watt and both ideal and system efficiencies. The green line shows that the ideal efficiency increase as the amount of heat losses increase. On the other hand, the system efficiency decrease as the amount of heat losses increase. So to increase the efficiency of our system, we recommend to increase the number of thermoelectrical generators, so at the same amount of heat losses, we increase the power generated through the thermoelectrical generators. Also, the system should be perfectly insulated to decrease the amount of heat losses. And the final recommendation is to install cooling system for thermoelectrical generators. Our future work will focus on how to make the system adjustable for different exhaust size. Also, to use the system in other areas, for example in industries where there is a pipeline and there is a waste heat from it. Now we will show you a video that explains the experiment.
Here is our experiment of project system, starting from the readings of mass flow rate sensors of fan speed that's regulated by voltage source, and then we have the duct which we put on it the heaters that's well insulated and will help us to deliver the heat to exhaust to get the specific speed and heat by the end that we wanted. Here is the voltmeter that get readings of produced voltage of the system, as we see. Also the cooling box which have the thermoelectric set which will have a delivery of electricity through the battery that's connected to MPPT and charging by the thermoelectric generators. We put eyes to one side of thermoelectric generators to have higher temperature difference, and that's to enable the system to get cooling, and that's what happened actually. The cooling system was well working. As a completion of simulation, three temperature sensors are added to get temperatures. Here's my friend at the cold ice to get high temperature difference. Three temperatures at beginning, middle and end, and we have here the readings by the Arduino on computer.
In conclusion, we show you different type of waste heat recovery technologies through the literature review. Also, we develop statistical data about the waste heat from exhaust car in Oman, where we found that there is an increase of waste heat from 2020 to 2021 by 3 gigawatt. Then we generate 5 concepts and evaluate them through different evaluation method. After that, we manufacture the selected concept, and then we conduct the experiment and record the results. The main finding from the results that the total voltage generated through the thermoelectrical generators is 4.13 volt, and we reach a maximum efficiency of 15.9%. That's all about our presentation. Thank you for your attention.